Hi everyone, our topic is called the elasticity of demand. I'm Felicia.
I'm Jinyi. I'm Kashin.
I'm Yushan.
To understand the elasticity of demand, first of all, we need to define the term elasticity in general. It is used to describe a measure of the responsiveness of quantity demanded or quantity supplied to one of its determinants. And as you guys can see in the picture, a completely horizontal line indicates perfectly elastic, while a completely vertical line shows perfectly inelastic. Elasticity of demand has three categories. They are price elasticity of demand, income elasticity of demand, and cross-price elasticity of demand. In our presentation, we'll go over each of them later on. First category we'll discuss is the price elasticity of demand. It is a percent change in quantity demand due to percent change in price. Its formula is percent change in quantity demand over percent change in price. As all of you guys can see in the picture, price elasticity of demand has 5 classifications. For example, if the percentage change in demand is the same as the percentage change in price, then it is inelastic. And if the percent change in demand is greater than the percent change in price, then it is elastic, like this. And vice versa. If the percent change in demand is less than the percent change in price, then it is inelastic, or like this. On the graph, we can tell that unitary elastic is always in the middle, and segment AC represents the elastic demand, and segment BC represents the inelastic demand. Here's just another graphic representation of elasticity of demand. The flatter curves like A indicates more elastic, while the steeper curve like E is more inelastic.
In this section, we are going to talk about point slope formula and midpoint formula. Point slope formula is change in quantity demand divided by change in price, which equals to Q2 minus Q1 over Q1 times 100 divided by P2 minus P1 over P1 times 100. Here is an example. When the price of good A is $50, the quantity demand for good A is 500 units. When the price of good A rises to $70, the quantity of good A falls to 400 units. Using the point slope method, the price elasticity of demand for good A is. Let's figure out the price and quantity first. In this case, P1 equals to $50 and Q1 equals to 500 units. P2 equals to $70 and Q2 equals to 400 units. By using point slope formula, we use 400 Q2 minus 500 Q1 over 500, which is Q1, divided by $70 P2 minus $50 P1 over $50. The final answer is negative 0.5%. Therefore, a 1% increase in price corresponds to 0.5% decrease in quantity demand, and decrease is because 0.5 is negative. Next, we are going to explain midpoint formula, which also is change in quantity demand over change in price equals to Q2 minus Q1 over Q2 plus Q1 divided by 2 times 100 divided by P2 minus P1 over P2 plus P1 divided by 2 times 100. Here is an example. When the price of good A is $50, the quantity demand of good A is 500 units. When the price of good A rises to $70, the quantity demand of good A is 800 units. Using the midpoint method, the price elasticity of demand for good A is. Let's figure out the price and quantity. In this case, P1 equals to 50, Q1 equals to 500, and P2 equals to 70, Q2 equals to 800. By using midpoint formula, we use 800 Q2 minus 500 Q1 over 500 Q1 times 100 divided by $70 P2 minus $50 P1 over $50 times 100. The final answer is 1.5%. Therefore, a 1% increase in price corresponds to a 1.5% increase in quantity demand.
This part is about total revenue and price elasticity of demand. Assume we sell two different products, which is product 1 and product 2. Product 1 has inelastic demand because the graph is steeper, and product 2 has elastic demand because the graph is flatter. Also, we can use midpoint formula to test which one is inelastic or elastic. From the graph, we can see when a product has elastic demand, the price decreases while cost to the revenue increases. And when a product has inelastic demand, the price decreases while cost to the revenue decreases. Therefore, in order to increase total revenue, we can decrease the price of a product that has elastic demand and increase the price of a product that has inelastic demand. This part is about elasticity along a linear demand curve. The slope of a linear demand curve is constant. We can pick up two price at which is at $5 when a quantity is 0 and price is $4 when quantity is 1. We can use slope formula, which is we can get the slope is -1. As we keep getting the slope, it's always being -1, which is constant. But the price elasticity is not constant. We can use midpoint formula to get the price elasticity, which is percentage change in quantity demand divided by percentage change in price. For two example, at price is $5 and quantity is 0. We can use 200% divided by -22%, which is -9.1. At $4 and quantity is 1, we can use 67% divided by -29%, which we can get -2.3. From these two examples, we can see the price elasticity is not constant.
Income elasticity of demand. The formula is the percentage change in quantity demand over the percentage change in income. Nancy's income rises from $22,000 to $24,000, and the quantity of donuts she buys each week falls from 2 pounds to 1 pound. By using the income elasticity of demand formula, the percentage change in quantity demand is -0.66, and the percentage change in income is 8.69. So the result is -0.64, which means every 1% increase in Nancy's income corresponds to a 0.74% decrease in quantity demanded of donuts. Therefore, this is an inferior good. The cost price elasticity of demand formula is change in quantity X over quantity X divided by change in price over price. The price of potatoes rises from $2 per pound to $2.5 per pound. As a result, the quantity of corns demanded rises from 5,000 per week to 7,000 per week. By using cost price elasticity of demand formula, we got the quantity change divided by quantity is 0.4, and the price change divided by price is 0.25. So the result is 1.6, which means a 1% increase in the price of potatoes corresponds to a 1.6% increase in the quantity demanded of corns.